Okay, in this ACT video, we are going to look at similar figures. Before we get started with any examples, we need to review the properties of similar figures. And we're going to go over three properties here. First of all, the figures have to be the same shape. They're going to be different sizes. So we have to be looking at two similar triangles or some similar trapezoids. They're definitely not similar if it's a triangle and a trapezoid. With similar figures, the corresponding angles are congruent, so that's good. You don't have any math to do there. And the corresponding sides are proportional, so that means we're going to be setting up a proportion and cross multiplying. Now let's talk about some symbols here. First of all, this is our symbol for similar. And say we're talking about some similar triangles, like we say triangle XYZ is similar to triangle ABC. The cool thing about similar figures is when you list the statement here, the statement of similarity, the order that these letters are written is very important. So in this case, I don't even have to have the two figures, and I know because X is the first letter and A is the first letter that the measure of angle A is equal to the measure of angle X, or X equal to A. Similarly, Y and B. Angle Y is equal to angle B, and then that would make angle Z equal to angle C. So not only can I figure out which angles are congruent, but I can also talk about the sides because these first two letters are side XY, and it corresponds to side AB. And so also side YZ corresponds to BZ because those are the last two letters. And then, let's see if you can follow me here, side XZ corresponds to side AC. Now, chances are you're going to be given the figures, but they may not match up exactly, so it helps to know this little trick that the order that the letters are written in actually means something. All right, so let's look at an example now and solve for some missing sides. All right, we've got triangle ABC is similar to triangle XYZ. Find the length of YZ and the measure of angle X. So these figures are down below and there's some given information. Angle A is 40 degrees, side AB is 4, side BC is 6, and on the big triangle, all we have is side XY is 10. Now, because we're being asked to find the length of a side, YZ, what if I just put a little, maybe like a lowercase x, so I have an unknown there. You don't have to do that, but I find it helpful. And when I'm asked to find the measure of an angle, this one seems to be fairly obvious. So I'm going to go ahead and knock that out because angle A is listed first and angle X is listed first. So that means they're congruent. So angle A is congruent to angle X. Therefore, we can go ahead and state that the measure of angle X is equal to 40 degrees. Okay, so that's done. Now let's talk about the sides. Let me get my highlighter tool out here. Let's look at side AB. That's given 4. So we're going to have to use some of that. AB is my first two letters, so I know it corresponds to XY. XY is here. So this is kind of good in the sense that these two triangles appear to be what I call matchy-matchy. The corresponding sides are in the same positions. In other words, one of the figures isn't rotated. All right, then we have the given information that BC is 6, and BC, that's these top two letters, corresponds to YZ. These last two letters, I said top two, but these last two letters, BC, correspond to YZ, which is the side we're looking for, which is excellent. So I can refer to these by color now. The turquoise side on the small triangle refers to the turquoise side on the big triangle. This purple side on the small triangle corresponds to the purple side on the big triangle. So we want to set up a proportion. That means everything needs to be matchy-matchy or correspond. So we'll say 4 over 10 equals 6 over x. Now notice the 4 and the 6 up at the top, that comes from the small triangle, triangle ABC, and those denominator pieces, 10 and x, those come from triangle XYZ. So everything corresponds. It's not 4 over x or anything like that. Everything's real left to right, matchy-matchy. All right, once you have your proportion set up, you're just going to cross multiply. X times 4 is 4x. 10 times 6 is equal to 60. Divide by 4 on both sides. Divide by 4 on both sides. And 60 divided by 4 gives me 15. So we can say that side YZ, since we just labeled it lowercase x for ease of solving, YZ is equal to 15. And we already gave angle X is 40 degrees because the angles are congruent. All right, this one's pretty straightforward. The next one I'm going to give you, though, has a little curveball in it. Two things here. We've got triangle PQR is similar to triangle YXR. What is the measure of QR? Well, this is a common way to see similar triangles or similar figures of any kind. And by what I mean by that is this triangle XYR, let's highlight it. It's sitting on top of the big triangle PQR. See that? So what I would recommend doing, especially if you don't see it right away, is separate the two triangles. So let's draw the big triangle, this one right here. I'm just going to highlight it for reference purposes. And I'm going to draw it. I'm not going to draw it quite as big just because I don't have enough room here. And then I'm going to draw my little XYR in purple. Okay, they're not to scale, but you get the idea. Just so it's easy to see. Okay, that's Q. We have a right angle. That's P. We have R. This is a right angle. X, Y, and R. Now we need to label the pieces so we can set up our proportions. And that big line down here, that 36, it stretches out to PR. So that's 36. And on the pink triangle, we have XY is 15. And on the pink purple triangle, whatever we want to call it, YR is 20. Okay, so that was your first curveball, is that the little triangle was on top of the big triangle, and I would recommend separating it, just drawing two new triangles. Now, here's the second curveball. The corresponding sides, PR, this one's right here, corresponds to YR. That's great. But what we're looking for is the measure of QR. So we're looking for the hypotenuse piece. And over here, I don't have the hypotenuse piece. And the hypotenuses have to correspond. So this just turned into a two-step problem. In a previous video, we learned how to solve for missing pieces of a right triangle. So we're going to first take our purple triangle, triangle XYR, and we're going to have to do the Pythagorean theorem to find that missing piece. So that's going to be leg squared, 15 squared, plus leg squared, 20 squared, is equal to, let's just label that hypotenuse C, and that's C squared. So 15 squared is 225, plus 20 squared is 400, equals C squared. 225 plus 400 is 625, equals C squared. We have to take that square root on both sides, so the squared and square root cancels, and the square root of 625 is 25. So now we have the hypotenuse, which is 25. So now we can set up our proportion because we know that PR corresponds to YR. So this will be our second step in this problem. Now setting up the proportion, 36 over 20 equals, let's just call that hypotenuse on the blue one maybe an X again, X over 25. So I did leg over other leg equals hypotenuse over other hypotenuse. Okay, notice everything in the top, 36 and x, that comes from the big blue triangle. 20 and 25, that comes from the little purple triangle. Everything's real matchy-matchy. All right, then we just cross multiply to solve. So that's going to be 25 times 36 is 900 equals 20 times x is 20x. Divide both sides by 20. 20's cancel, and x is equal to 45. And so what we did, just to make it a little easier to solve, we called QR, we called that x, so that means QR is 45. So watch out for that on the ACT, because what they're doing there is they're asking you two types of questions. Not only are they asking you to solve similar triangles, but then they're also testing you on the Pythagorean theorem. So that type is probably something you will see.